Air moves around the world transporting heat from tropical regions to polar regions. This is known as global air circulation. In this video, we will look at how our atmosphere functions at a more complex level, known as tri-cellular circulation. This circulation takes into account how the Earth is heated as well as the Earth's rotation. Let's recap a few concepts to refresh our memories. The equator is at 0 degrees, and as we move north or south of the equator, the latitude increases. We also need to recap the difference between high pressure cells and low pressure cells. High pressure cells are associated with cold, dense air that sinks, which brings about dry conditions, whereas low pressure cells are associated with warm, less dense air that rises, which brings about wet conditions. If we look at these systems working together, we can see how air diverges, which is when two air masses move apart from each other, and we can also see how air converges, which is when two air masses come together. We also need to remember that the sun heats up the Earth differently at different latitudes. You can watch my previous video on the Earth's energy balance for a more detailed description on this concept. Let's look at how differences in temperature affect global air circulation in this tricellular model. At the equator, it is hot, therefore warm air rises, creating a low pressure system. As air rises, it cools down. If condensation occurs, clouds form and there could be rain. Once the air has cooled, it will sink. It will then warm up and rise again, creating the first cell that we will look at, known as the Hadley cell. At the poles, it is cold, therefore cold air sinks, creating a high pressure system. As air sinks and diverges, it warms up and rises again. This creates the polar cell. Now, the cell in between the Hadley and polar cell is known as the Ferrel cell, which is driven by the movement of the Hadley and polar cells. These cells form in both the northern and southern hemisphere as mirror images of each other. Wherever air is rising, a low pressure belt is created, and these areas experience a lot of rainfall. This explains why tropical regions have large rainforests. Wherever air is sinking, a high pressure belt is created, and these areas experience little to no rainfall, creating desert areas. Now let's have a look at how Earth's rotation impacts global air circulation within this tricellular model. Remember that Coriolis force is the deflection of wind because of Earth's rotation. Winds deflect in different directions in the northern hemisphere and the southern hemisphere, and Ferrel's law can help us determine in which direction our wind is going to deflect. Standing with your back to the wind, winds deflect left in the southern hemisphere and right in the northern hemisphere. So, going forward, we need to use Ferrel's law and the knowledge that air always moves from a high pressure to a low pressure. So now that we've learned about our differences in high pressure and low pressure systems, we can understand how wind moves between these belts. So over here we have a low pressure, which is represented by LP, and high pressure is represented by HP. Remember, wind always moves from a high pressure to a low pressure. So let's concentrate first on the southern hemisphere. Wind is moving from a high pressure to a low pressure. Over here, wind is moving from a high pressure to a low pressure, and over here, wind is moving from a high pressure to a low pressure. But now wind doesn't just move in a straight line because of the Coriolis force acting on the Earth. Wind is going to be deflected, and we can use Ferrel's law to help us remember which direction wind is going to be deflected. In the southern hemisphere, wind is deflected to the left. That means actually the wind is going to do that. So in the southern hemisphere, our winds actually look like this. Winds are always named based on where they are coming from, and so these are called our tropical easterlies, westerlies, and polar easterlies. In the northern hemisphere, winds are deflected to the right, which means that our winds actually look like this. Again, tropical easterlies, westerlies, and polar easterlies. And that is it for global air circulation. It can be confusing, but just remember, take it one step at a time and don't forget your rules. Hope it was helpful. Thanks for watching, and I'll see you in my next video.